Good morning, everyone. So today we continue our topic, that is the vapor pressure of pure solvent. So in previous class we discussed the vapor pressure of pure solvent. So just a little bit of explanation. In one container, some amount of liquid is taken. So these liquid particles are converted into the vapors. So the process is called as a liquid is converted into vapors, and this process is called boiling or vaporization. We can call boiling or vaporization. Then after occupying the space, so again these vapors are converted into the liquid. So that is the reversible process, and the reversible process is called as a condensation. Condensation. At one situation, vapor, condensation, boiling, both are in an equilibrium state. At equilibrium state, these vapor particles are created with pressure on the surface of liquid, that is called as a vapor pressure. Up to this much of the portion completed. So now, effective factors affecting the vapor pressure. So vapor pressure affecting factors of vapor pressure. So now, mainly these vapor pressure is affected by the mostly two factors. So first factor is the temperature. First affecting factor is temperature, and second affecting factor is temperature, and second affecting factor is nature of solute and solvent also, both nature of solute and solvent. So first of all, temperature. Obviously, for example, in one container, see, this is the container. In container, liquid is taken. If you boil that, when you boil the liquid, so between the particles, so some intermolecular attraction forces are present. On boiling that, these intermolecular forces are breaked. I mean, they become weak. If intermolecular forces are weak, so these liquids are converted into vapor. Means on increasing the temperature, evaporation is increases. If evaporation is increases, automatically number of particles are increases and they are converted to liquid. And at equilibrium state, this pressure is called as a vapor pressure. So obviously, on increasing the temperature, vapor pressure is increases. So temperature increases. So vapor pressure also increases. Also, it explained by the graph. Graphical representation also is there. So this is the graph. In a graph, along the x-axis we are taking the energy. Along the y-axis, fraction of molecule. Fraction of molecules are taken. Here we are discussing about only the pure liquid, not a solution. So first temperature. For example, this is the curve by the plotting of energy versus fraction of particles. So this is the first temperature T1. Next second temperature T2. Next third temperature T3. T1, T2, T3. Different temperatures are there. So obviously T1 less than T2, T2 less than T3. Different temperatures are there. For example, we can take one imaginary point, energy, at a fixed point. Energy is fixed here. For example, this is the energy of E0. Okay, E0 energy. At E0 energy, so at T1 temperature, this is the particle. At T1 temperature, how many particles are involved here? This number of particles are involved in a boiling process. So this is the number of particles involved in T1 temperature. When we increase the temperature, this is the T2. At T2, fraction of particle. How many particles are involved? So this total number of particles are involved in a boiling process. Then at T3 temperature, these are the number of particles which can be involved in a boiling process. How can we show that? See, this is the total area. Okay. So at T1 temperature, T2 temperature, T3 temperature. On increasing the temperature, vapor pressure is increases. So vapor pressure T1 temperature, vapor pressure T2 temperature, vapor pressure T3 temperature. Obviously, T3 greater than T1, T2, T2 greater than T1. So इसका मतलब है affecting factors of vapor pressure. Vapor pressure को affecting factors. जनरली वेपर प्रेशर दोनों फैक्टर्स का इफेक्ट हो जाता है, दोनों फैक्टर्स से इफेक्ट होता है। एक है टेम्परेचर और दूसरा है नेचर ऑफ सॉल्यूट एंड सॉल्वेंट। इसके फर्स्ट इफेक्टिव फैक्टर के अंदर जितना टेम्परेचर बढ़ाते जाएंगे तो पार्टिकल्स के बीच में इंटरेक्शन फोर्स कम हो जाता है। जब इंटरेक्शन फोर्स कम होता है तो पार्टिकल्स वेपर्स होना शुरू होते, जब वेपर्स होते तो ऑब्वियसली उनका प्रेशर भी बढ़ जाता है, मतलब टेम्परेचर को बढ़ाने से वेपर प्रेशर बढ़ते जाता है। उसका एक ग्राफिकल रिप्रेजेंटेशन है, एक ग्राफ। अब मान लो यहाँ पे तीन टेम्परेचर्स है, T1, T2 एंड T3 टेम्परेचर। तीन टेम्परेचर है। T1 टेम्परेचर इज लेस देन T2, T1 से कम T2 है, T2 से कम T3, T1 T2 से कम है, T2 T3 से कम है। सो T1 टू T3 टेम्परेचर इंक्रीजेस। मान लो अब T1 टेम्परेचर का ये फिक्स्ड एनर्जी डिफरेंट टेम्परेचर से, ये T1 टेम्परेचर का पॉइंट, T2 पॉइंट एंड T3 पॉइंट। अब T1 टेम्परेचर पे फ्रैक्शन ऑफ मॉलिक्यूल कितने फ्रैक्शंस है, ये फ्रैक्शन ऑफ मॉलिक्यूल है T1 टेम्परेचर, और ये T2 टेम्परेचर के फ्रैक्शन ऑफ मॉलिक्यूल कितने हैं। अगर T3 टेम्परेचर लेंगे तो फ्रैक्शन ऑफ मॉलिक्यूल ये सारे फ्रैक्शन। अब देखो T3 टेम्परेचर में ज्यादा पार्टिकल्स इन्वॉल्व है, T2 में कम पार्टिकल्स इन्वॉल्व है, T1 में और उनका कम पार्टिकल्स है। मतलब ऑन इंक्रीजिंग द टेम्परेचर, जितना टेम्परेचर बढ़ते जाता है तो फ्रैक्शन ऑफ मॉलिक्यूल्स इंक्रीजेस, देन फ्रैक्शन ऑफ मॉलिक्यूल्स इंक्रीजेस, वेपर प्रेशर इज इंक्रीजेस। सो दिस इज द फर्स्ट एक्सप्लेनेशन ऑफ टेम्परेचर। टेम्परेचर का फर्स्ट एक्सप्लेनेशन है। और दूसरा सिंपल एक्सप्लेनेशन है, वेरी इंपॉर्टेंट एक्सप्लेनेशन, दिस इज द मोस्ट इंपॉर्टेंट टर्म, that is ideal gas equation। ideal gas equation क्या है, PV is equal to nRT। इसको मॉडिफाई कर दो, so P is equal to n by V RT, this is modified। the ratio of mole number and volume is indicate the concentration term, so n by V is equal to concentration, so P is equal to CRT। okay, अगर टेम्परेचर कांस्टेंट लेंगे so constant into constant is one of the constant। okay, तो मान लो since CR is equal to K, एक कांस्टेंट मान लो, तो P is equal क्या होता है KT। when we remove the constant proportionality is obtained और remove the proportionality constant is obtained, so finally क्या होता है P directly proportional to T। ये भी एक सॉलिड रिप्रेजेंटेशन है। जितना टेम्परेचर बढ़ता तो उतना प्रेशर बढ़ता, प्रेशर वेपर प्रेशर आल्सो बढ़ेगा, so that is the relation between the temperature and vapor pressure। so direct relation is pressure, temperature is directly proportional to temperature is directly proportional to pressure। ये दो रीजंस है, एक तो टेम्परेचर ग्राफिकल रिप्रेजेंटेशन एंड सेकंड वन इज द आइडियल गैस इक्वेशन, रिलेटेड टू आइडियल गैस इक्वेशन। सो नाउ नेक्स्ट फैक्टर इज नेचर ऑफ कंपाउंड। नेचर ऑफ कंपाउंड, इफेक्टिंग फैक्टर दैट इज द नेचर। मान लो एक लॉजिकल एक्सप्लेनेशन, एक कंटेनर है, कंटेनर के अंदर एक लिक्विड के अंदर लिक्विड पार्टिकल्स है, लिक्विड पार्टिकल्स के बीच में इंटरेक्शन फोर्स जितना ज्यादा रहता, इफ लिक्विड पार्टिकल के बीच इंटरेक्शन फोर्स जितना ज्यादा रहता उतना वो कम ऊपर जाता है। अगर ये इंटरेक्शन जितना कम है तो उतना ज्यादा ऊपर जाते हैं, उतना ज्यादा प्रेशर क्रिएट कर सकते। सो मेनली नेचर ऑफ कंपाउंड इज डिपेंड्स अपॉन इंटरेक्शन। So if the liquid particles, solvent particles are interacted more, if they are more interacted, they does not convert it into vapors and created the pressure। If the interaction is less, little bit of less interaction, so they can easily convert it into vapor and created the pressure। So direct relation is vapor pressure is the inversely proportional to interaction। Vapor pressure is inversely proportional to interaction between the particle। If the interaction between the particle is simply intermolecular forces, if the intermolecular forces are increases, so obviously vapor pressure is decreases। So this is the inversely proportional। Again intermolecular force order, so hydrogen bond, force of hydrogen bond is greater than the dipole dipole, again dipole is greater than the van der Waals force when we compare them। So generally on increasing the interaction vapor pressure decreases, but in interaction also different type of interaction is there। So first one is the hydrogen bonding, is the dP force and third one is the van der Waals force. So first priority should be given to the hydrogen bond. Again dP force. Then next one van der Waals force. If when we compare the two components, component 1 and component 2, in this component, for example, same van der Waals forces are there. Van der Waals force, same forces are there. So that time we have to give the first priority order. Which order? Based on the atomic radius and mass. For example, some components are there. Chlorine is not chlorine, bromine, iodine. Okay. In a order, chlorine same van der Waals force, bromine also van der Waals force, iodine also van der Waals force. In case of that, so van der Waals force is maximum. Van der Waals force is less van der Waals force in chlorine and maximum van der Waals force in iodine. Van der Waals forces are increases from where? Chlorine to bromine. Sorry. Van der Waals forces are increases from where? Chlorine to bromine, bromine to iodine. Okay. If van der Waals forces are increases, so automatically vapor pressure decreases. So this is the sequence of van der Waals force. Again, order of vapor pressure. CL2 greater than Br2 greater than I2. This is the order of vapor pressure. Okay. So this is the topic effect factors affecting the vapor pressure. So mostly vapor pressure is affected by the two factors. Important two factors are there. First one is the temperature. Second one is nature. Okay. Then next. So next one, vapor pressure. Let's consider generally vapor pressure is equal to mostly vapor kb, or we can write that kbr. See, kp, kb. Pressure constant is generally equal to vapor pressure, or we can write P. Pressure of vapors mostly constant. Kp is equal to pressure of vapor constant. Let's consider at T1 temperature. Kp pressure constant Kp is at T1 temperature. Then next when we increase the riser temperature T2. At T2 pressure constant Kp is T2. If you know that Kp T1 temperature at Kp at T1 temperature, Kp at T2 temperature. So then that comparison equation is log Kp T2 by Kp T1 is equal to delta H divided by 2.303 R. 2.303 R into 1 by T1 minus 1 by T2. This is the equation. So, अगर मान लो generally कभी भी ये Kp है ना pressure constant किसके equal है? The vapor. इसका through देखिए. Generally liquid लेना है. Liquid को जब हम boil करते हैं तो क्या होता है? Gas में convert होता है. That is converted into vapors. Again vapors क्या होते हैं? Liquid में convert होते हैं. Forward reaction is boiling. And backward reaction is the condensation. Boiling and condensation. अगर हमको इसको इक्विलिब्रियम कांस्टेंट पे लिखना है Kc नहीं लिखना, क्योंकि हम प्रेशर को कंसीडर कर रहे हैं Kp is equal to pressure of product by pressure of reactant. So pressure of product is pressure of vapors divided by pressure of liquid. Okay. Generally concentration of liquid or pressure of liquid always is equal to 1. So that's why this equation is converted. Kp is equal to pressure of vapor. So this is the proof. Okay. And अब देखो क्या करना है? T1 टेम्परेचर पे Kp वैल्यू Kp T1 है, T2 टेम्परेचर Kp T2 है. अगर मान लो दो कंडीशन को कंपेयर करना है, दो सिचुएशन को कंपेयर करके कैलकुलेशन करना, ये टाइप इसके ऊपर क्वेश्चंस नीट एंड जेईई मेंस लेवल में ज्यादा क्वेश्चंस आते हैं. दिस इक्वेशन रिलेटेड इक्वेशन क्या है? log Kp T2 मतलब log T2 टेम्परेचर पे Kp वैल्यू divided by T1 temperature by Kp value is equal to enthalpy, change in enthalpy divided by 2.303 R. ये R value कभी कितना लेना है? R is equal to 0.08321 bar atmosphere per mole per Kelvin, but into 1 by T1 minus 1 by T2. अब देखो ये T1 T2 क्या है? दो सिचुएशन, इनिशियल फाइनल. इनिशियल टेम्परेचर इज T1, फाइनल टेम्परेचर इज T2. Initial rate का pressure constant is Kp, final pressure constant is Kp T2, Kp T1. So by knowing this value, we can calculate anything. Initial Kp or final Kp, whatever. So this is the vapor pressure of pure liquids, not a solution. Next class we discuss the vapor pressure of the solutions.